To ensure students master both the concepts and application in this course, we are introducing labs in R with real-world data that enable students to seamlessly apply what they've just learned to solve real-world problems without the hassle of learning how to set up an integrated development environment on their own, graded within Wiley+. Within each chapter, there's a final section with lab projects. Each lab covers several key topics within that chapter, and students are shown all the steps that are necessary in the R programming environment, but can work directly within the browser. Here we see students being shown a linear regression problem where they are using an R function to solve a regression analysis of several data sets which have been preloaded for them into the R environment. Each programming task has several multiple choice questions as well as open-ended R coding problems to apply the theory they just learned in that chapter. You can see I can look at a hint to see how to solve this problem, and there's good syntax support. In fact, each command has a pop-up window with a tutorial showing you how to use that command. So students literally need nothing other than the browser window at hand to learn enough R, the key most interesting parts of R, without the technical hassles. Once they've made an attempt, they are able to actually see the solution. Of course, we could make that a partial solution, or we could provide them with a template that they only have to fill in a few parts of it. But once they've typed in the solution correctly, they're able to find the solution. And you can see when they correctly type the solution, they're able to evaluate it. Of course, whatever they type in here, as long as it's valid R code, they'll get the evaluation result, but they won't get the correct solution unless they put in the correct code. This isn't graded right here as a side note, but we could quite readily check for correct output. In this case, the way output is checked for is questions are asked about the solution to see that they've gotten the right parameters out. So now we're going to produce a nicely formatted coefficients table using the cable command. And again, since I don't know how to do it, I'm just going to show the solution, which I can only do after actually trying the problem ostensibly. And then I can now see the coefficients. Now, I'm being asked to interpret the coefficients of whether we're statistically significant. And since I know enough here, I think t-value versus a standard error. Actually, I don't know enough. Probability or t. Anyway, so I'll have to answer if it's statistically significant. And first I have to get it wrong. That's the long form answer. I should have picked one that shows here. Here's a multiple choice one. There's actually qualitative answers and answers where you have to type in a number, objective questions, as well as free form ones that are not in this case. In this Carnegie Mellon lab we're looking at, they're not graded automatically. And then let's see how we do that. I think this is more of the same. Okay, so we're constructing a confidence interval for the coefficient of MPG highway, and then there's a little learning module where you actually have interactivities where you can change the lambda in the problem here. That's this slope of x3 with respect to x1, and you can see how it changes the actual output of the problem, the standard error, etc. So, I mean, all in all, basically a super easy way for students to learn some pretty important applications of engineering statistics, or statistics to engineering and other real-world science and engineering problems. And all with little overhead for the instructor. We can have a printable PDF instructor guide with just the solved versions of all these problems that are handy for them to refer to if they need. Again, the R code is all here in a tutorial form, and help syntax is, little help links are readily available everywhere. The data sets are embedded and automatically loaded, so there's just no hassle. There's no syntax errors that are not specifically in the problem themselves that need to be solved by the students. And we can, of course, template these up front if we don't want to make the students even do the entire typing we have here. We could have partially filled in with blanks that they can fill in. So at least they're getting a simulated kind of foolproof, if you will, environment to work in that will be incredibly useful to them and can be potentially auto-graded in Wiley Plus, or in Canvas through the R engine for Canvas, which there is such a thing. So let me know if this is interesting. This is so cool.